Hello and welcome to a little video about 7a, which is the Pythagorean Theorem. Today we're just going to focus purely on the mathematics and then we'll do some applications later. Now the reason we have to go over the Pythagorean Theorem, even though I know you know about it, is because we're going to learn about trigonometry. Trigonometry is based on right triangles, which are the only thing we can apply Pythagorean Theorem to, which also means we're going to have to use the Pythagorean Theorem during some trigonometry. Let's get into it. A right angle is an angle who has 90 degrees. A right triangle is a triangle with exactly one 90-degree angle. It is impossible to have a triangle with two 90-degree angles. At least not in this universe. Not at this time. Now, when we have right triangles, we can apply the Pythagorean theorem, which is a squared plus b squared equals c squared. A and b stand for the legs of our triangle, which are the two shorter sides surrounding our right angle, and c represents our hypotenuse, which is the longest side and will always, always, always be across from our right angle. As a side note, it was discovered by Pythagoras, which is why we call it the Pythagorean Theorem. And this was discovered in ancient Greece. It's crazy to think that there was a time where people didn't know that the Pythagorean Theorem existed. That, it's just, maybe that's the nerd in me being baffled, but this Pythagorean Theorem changed a lot of things for us as humans in our development. This video is not about history, so we won't talk about that right now. Let's do some math. How about that? Okay, so here is number 1. Let's solve for a. And this is the Pythagorean Theorem. A squared plus b squared equals c squared. The first thing I'm going to do is simplify. Whoa, that 2 is too big. So instead of 4 squared, I'm going to write 16. Instead of 5 squared, 25. I'll solve it by subtracting 16. And I get a squared equals 9. In order to get rid of a square, we square root both sides. Now usually when we square root, we write positive negative as our answer. But we're talking about triangles. There's no such thing as a negative measurement. So a has to be positive, and the answer is 3. Onwards we go. Let's try out number 2. Once again, let's simplify. 10 squared is 100. We don't know what b is. 26 squared is, oh boy, 676. Let me double check. Yep. Okay, good. Oh, let's solve for b by subtracting. I'm trying to change the color here. OneNote. Let's do this. There we go. Let's subtract 100 from both sides. And I have b squared equals 576. And just like before, we need to square root both sides in order to get b by itself. I feel like I said 74 for some reason. I think I may have accidentally said 574. Clearly it's 576 right there. Okay, let's square root both sides. Remember, this is a triangle we're thinking about, so we're only going to have a positive answer. The square root of 576 is 24. Alrighty, not too bad, not too bad. Let's continue. Number 3, we're looking for c. This one will be an easy one. 8 squared is 64. 10 squared is 100. Let's add them. We have 164 equals c squared. And all we have left to do here now is square root both sides. And, unfortunately, there is no perfect square that gives us 164. The instructions say let's round to the nearest hundredth, so we get 12.81. And that happens. Not all right triangles will have perfect sides. The ones that do, by the way, like number 1 and number 2, those are called Pythagorean triples. They're perfect numbers that work with the Pythagorean theorem. The most common ones you're going to see are in number 1, that 3, 4, and 5. And there's a couple others that you will see in the next example. So let's check it out. Ooh, so okay, so number 4 and number 6 are also pretty common Pythagorean triples. Okay, so our Pythagorean theorem states that we're going to take both of the legs, square them, and that equals our hypotenuse. So we have 5 squared plus 12 squared equals c squared. Right? So that's 25 plus 144 equals c squared. 169 equals c squared. Square root both sides. Of course, we do have a triangle. Has to be positive. 13 is our answer. 5, 12, 13 is one of those Pythagorean triples that you will see pretty often. Let's go down to 6 to see another one of these Pythagorean triples. Then we'll do number 5. Okay, so, oh, that's b squared. Okay, so we have b squared for one of our legs, 40 squared for another, and 41 squared for our hypotenuse. That looks like a 7. Let's try that again. 1. Beautiful. All right, let's simplify. B squared plus 1600. Just checking because my brain is, yeah, okay, good. Then 41 squared is going to be 1681. Let me double check that as well, just in case. Okay, good. Okay, let's solve for b by beginning subtraction. Okay, so we have b squared equals 81. And let's square root both sides. B equals 9. Alright, so 9, 40, 41 is a Pythagorean triple. I guess that one's not, I don't see this one as often. I see the 7, 23, 25 one more often, but this is a perfect one that does show up. Right. Lastly, let's do number 5. Telling you right off the bat, this one's going to be a funky answer. It is not a Pythagorean triple. We are given 2 legs, so we have 2 squared and 7 squared equals our hypotenuse squared. So that's 4 and 49. 4 plus 49 gives us 53. And 53 is not a perfect square. So what we're going to have to do is square root it in our calculators and round to the nearest hundredth. Okay. Square root. The square root of 53, according to my calculator, is 7.28. So not a perfect triple here. We do have some decimals, but that's fine. It's a right triangle, which means we can apply the Pythagorean theorem. And that's really all that matters. Okay. I hope this was a decent review of the Pythagorean theorem for you. Sorry for my stumbling and saying the wrong numbers, even though I wrote them down correctly. I'm just going to blame it on a Friday, because that's the day that I'm filming this. If you have any questions, make sure to ask myself or your teacher. Otherwise, have a wonderful rest of whatever day it is for you. Bye!